Free energy summary. Positive delta G, not spontaneous. Negative delta G, spontaneous. Delta G is delta H minus T delta S. So, when delta H is negative and delta S is positive, you're going to have negative minus a positive number, so you will always get a negative delta G, so it will always be spontaneous. When you have a positive delta H and a positive delta S, you're only going to have a negative delta G when this term is greater than delta H. When delta H is negative and delta T is negative, your spontaneous is at lower temperatures because this term has to be less than delta H. But when delta H is positive and delta S is negative, it's not spontaneous ever because your delta G will always come out to be positive. Now let's look at our relationship between K, our equilibrium constant, and E. Okay? At equilibrium, delta G is 0, E is 0, and E, remember, is our voltage, it's our electrical potential, okay? In electrochem terms, a dead battery is at equilibrium, okay? When delta G is positive, the reactants are favored. When delta G is negative, the products are favored. Spontaneous, non-spontaneous. Okay? And then here's some graphs that I know the first one got cut off. Not quite sure why that is listed there as a W. It should be your yield sign. And the same there. Okay? And delta G not only tells you whether something is spontaneous, it tells you the maximum work. Delta G is the energy available to do work. If it's non-spontaneous, it represents the amount of work that you need to put in order for it to go. And so we've got a diagram there showing about the battery and how the battery gets charged in one direction and the battery gets discharged in the other direction.